Hi everybody, this is Mr. Rocco, and today we're going to be exploring how minerals can form in caves. So in this Quest check-in lab, we're going to be reviewing the concepts we've been learning about in the reading, and we're going to be doing an experiment to better understand how minerals form. So the question we're going to be investigating is how can you make models of a cave feature such as stalactites and stalagmites? So as if you visit a limestone cave, you will see the effects of thousands of years of weathering and erosion. Two of these effects are stalactites and stalagmites. Stalactites look like rocky icicles that extend down from the roof of the cave. Stalagmites look like the upside-down stalactites that rise up from the cave floor. Both of these structures form very slowly from dripping water that contains dissolved minerals. In some caves, the rate of growth is estimated to be about 4 centimeters every 100 years. So this first paragraph right here is going to be very important for you to study and review. As you're working through this Quest check-in, you're going to want to refer back to this paragraph. It's giving you some information, background information about how do these really neat structures and caves form. We're also going to, in this quest, we're going to revise the script for the movie, The Deep Drill. So before break, we did a lesson where we had a movie script about the deep drill, and the professors were discussing and talking about where would be the best location to drill into the earth. So we're going to look at another scene from this movie, and in this check-in lab, you're going to model the formation of stalactites and stalagmites, and we're also going to write a new scene for the movie. In the scene, the characters are going to visit a cave and discuss its structures. Alright, so the materials for this lab are shown right here. We're going to be doing this in class as a demonstration. So each hour will have their own demonstration stalactite set up and growing. And we're going to be observing that each day. If you're at home as a distance learner, there's a video, the first video in Schoology, that goes over this experiment, and it shows you a demo video of about 4 different examples that were grown in different conditions, and you can see how the crystals form and how it changes. So if you watch that video, you can get the same observations from doing the lab. You can also try it at home if you have some simple materials like 2 glass jars, a piece of yarn, and some baking soda. So before we get into the lab, we're going to do some pre-lab questions. It says, observe the photo of the stalactites and stalagmites. What questions do you have about the way they form? So this is a photo from inside a cave, and you can see some of the different features are shown. So stalactites are the kind of long pointy spikes coming out of the top of the cave. The stalagmites are the kind of pointy spikes coming out of the ground of the cave. And all of these features form in a cave as water drips and enters the cave. Minerals that are dissolved in the water are left behind, and these structures build up very slowly over time. So take a look at this picture, hit pause, and when you're ready to answer the next question, you can click play again. It says, observe the photo of the stalactites and stalagmites. What questions do you have about the way they form? So I want you to come up with a few questions. So I'll just give you an example of one question I have here is, where does the water come from that enters the cave? Another question I have is, what minerals are left behind to form the stalactites? Okay, so just you're going to come up with a few questions that we're going to try to answer as we work through this Quest check-in. Next question, it says develop models. Read the steps of the procedure. Why do you think you should add as much baking soda as will dissolve in the water instead of only adding a few spoonfuls of baking soda? So when we set this experiment up, we are going to have 2 glass jars filled with hot water, and then we're going to put baking soda powder into both of the jars. And we're going to put as much baking soda into the jars that can dissolve So I want you to think about, why would we do that? In a real cave, minerals are dissolved in water, and those minerals are left behind when water drips from the ceiling. So we're going to set up a similar scenario in our experiment. So what do you think the baking soda is being used for, and why should we have as much of it in there as possible? Okay, so you might answer this question by saying something like, I think it is important to have as much baking soda So I think it is important to have as much baking soda as possible in the water because, and then you can finish that sentence. So what is the reason we're using the baking soda? What is the baking soda going to help us do to create these stalactites and stalagmites? All right, then it says use models. In the procedure, the mixture of water and baking soda represents the groundwater that weathers and erodes the rocks of a cave. What materials do you think the baking soda represents? Okay, so they're saying that in this experiment, the mixture of the water and the baking soda is going to represent the groundwater that would go into a cave that would erode the rock of the cave. And so it's saying in our experiment, what do you think the baking soda is going to represent? So is it going to represent the water? Is it going to represent the minerals that are left behind when the water evaporates? So I want you to write what you think. So I think the baking soda represents the, and you can finish the sentence. I think the baking soda represents the. All right, then it says, apply concepts. How do the materials you identified in the previous question become mixed into the groundwater? So it's basically asking you, if we know that there are minerals in the groundwater that are being left behind in the cave, where are the minerals coming from? So how do the minerals get into the groundwater? So you can say the minerals get into the groundwater when water dissolves the surrounding rocks. So as that water is percolating or traveling through the ground into the rocks, it picks up minerals that are in the soil and minerals that are in the surrounding rocks, and then those minerals can be left behind as they drip off, as the water drips off the ceiling from the cave. All right, so this is showing you the setup of the experiment. So if you're going to try this experiment at home, I want you to follow these directions. In class, we're going to do this experiment as a demonstration. So we're going to follow these steps. We'll talk about those in class. After we do this experiment, we're going to run this experiment for about 4 to 5 days. Each day in class, we're going to check on the progress of what is happening, and we're going to observe if anything starts to form in our experimental setup. And so you're going to work through these questions at the end of our experiment. So the first question says, compare your model stalactite and stalagmite with the actual cave structures shown in the photograph. How is the model like the real objects? How is it different? So when we're done with this experiment, I want you to go back and look at the pictures that I'll provide to you in class, and I want you to compare the stalactites that we made in the experiment compared to the structures that are in a real cave. Do they look similar? Do they have similar shapes? Are they the same color? Are they the same size? How are they different? How are they similar? Okay, for question 2, it says review your daily observations of the model Based on your observations, describe how real stalactites and stalagmites form in a cave. So you're going to use what we learned from our experimental model and how we grew crystals to explain the best you can of how stalactites and stalagmites form in a cave. So you might say something like this. Based on our observations of growing a stalactite, I believe in a cave they form when, and you can finish that sentence. So based on our observations of growing a stalactite, I believe in a cave they form when, and then you can kind of describe that process of what's happening. Okay, next question. Calculate the rate at which your rock feature formed. Compare this rate to the rate at which real stalactites and stalagmites form. So on average, we say that most stalactites grow about 4 centimeters every 100 years. So that's a really slow growth rate. It takes a very long time for these structures to grow in caves. Why do you think real stalactites and stalagmites form at a much slower rate? Consider factors such as the mineral content of the water and the water flow to construct a possible explanation. So when we are done with our experiment, we'll measure the size of our crystals and we'll try to figure out how much they grew each day. So you might say something like stalactites in a cave grow slowly because, and I want you to list a reason why it takes so long. Why do you think it takes so long for those structures to form? And what a stalactite is just minerals that have been left behind when the water is dripping off the cave. The solid is left behind. All right, predict. If you let the investigation continue for another week or longer, how do you predict the model stalactites and stalagmites would change? So if we ran this experiment for 2-3 weeks, what do you think would happen? Okay, so you would say something like, if we extended the experiment by 2 weeks, the following may happen. Okay, so you could just list the things that you think may occur if we were to do this experiment for a longer period of time. All right, the last part of this is where we kind of put everything together. It says, in this quest, you're one of the science experts for a movie called The Deep Drill. The movie is about scientists who are drilling into the Earth's interior. So they're not actually going there, they're drilling there. Write a scene for the movie in which the characters explore a cave to evaluate as a possible drilling site. The characters should encounter stalactites and stalagmites and discuss how they form. So in this movie scene, you should have you may have new characters, but you might have the characters from the last script we evaluated, which were Professor Santiago, Professor Kane, and Fran, but you're welcome to add new characters. But you should write about 4 or 5 sentences, and these should be dialogue, and your movie scene should describe exploring a cave as a possible drilling site, and they should encounter stalactites and stalagmites, and there should be a discussion about how these amazing structures formed in the cave. So you could have some dialogue about different hypotheses or ideas about how those different structures formed, and you could have them discuss their ideas, maybe do some testing. So I want you to show your understanding of how stalactites and stalagmites are formed by writing a short movie scene about 4 to 5 sentences long that explains that process. So we'll be working on this in class throughout the week, off and on. And if you're at home, start with that video. If you get stuck on something, you can send your science teacher a message in Schoology. Have a good day.